Welcome to module 7 of object oriented analysis and design. In the last module, we took a quick look into the evolution of programming languages, programming paradigms, and in the earlier modules, we had taken a look into the challenges of software development, of modeling complex systems, and we analyzed to understand a few common properties for complex systems. From this module onwards, we would try to use both these backgrounds to slowly start defining our object models, which is the fundamental concept of starting to analyze and design something in an object oriented manner. So, in this context, the current module will provide the foundations or talk about the foundations of the object model, and my main intention would be to introduce the three basic terms that we will frequently use, the notions of what is object oriented analysis, what is object oriented design. Often they are so interrelated that they are referred together as object oriented analysis and design, as is the title of this course, and we will get introduced to what is object oriented programming. The outline is available on the left. So, the object models, the foundation of object models certainly is in the object oriented analysis and design. Please note that this whole design analysis and design paradigm, the methodology, has been represents an evolutionary development and not a revolutionary one. What it means is, this is not a single path breaking thought or a path breaking approach by which you will quickly get a completely new solution. This is not coming and showing you that any set of numbers can be sorted in log n time without any extra memory. So, whoever solved that problem made a revolutionary solution, but object oriented analysis and design is typically an evolutionary development, which means that in the process itself, the approach is to start small, start simple, start elementary, and then evolve the system over a series of transitions into the final target complex system, and we will have to keep that in mind. And that is for the several different reasons that I have highlighted in the earlier modules. Going in an iterative evolutionary refinement form to go from simple to little bit more complex to even more complex to further complex and so on, and the final system is the only way to keep things under our control, to keep it within the human capacity of handling and manage the complexity to deliver a good working software. So, obviously, with algorithmic decomposition alone, only limited amount of complexity can be handled. We have discussed this at length. So, we turn to object oriented decomposition. If you historically look at, we just took one discourse in terms of the evolution of programming languages. In parallel, similar discourse you could study, but there is dearth of time, want of time, I could not cover them all in the historical perspective, but if you track in a similar way, the object oriented analysis and design is a direct fallout of advances in computer architecture, which has made it possible that different object based and object oriented features can be brought into the computing system. Advances in the programming languages, which we have already discussed, advances in programming methodologies like framework based programming, which also we have discussed, advances in database models, which has given us really new powerful ways to model databases, and this is growing, this is still getting much bigger than where our current course will stop. We have now databases which are called, say, no SQL database, unstructured data database. So, that is a regular evolutionary process that is going on. Even research in artificial intelligence, which has shown us that how much the reasoning can be structured, how much the reasoning can be automated, even advances in philosophy, cognitive science, understanding of our own thinking process have all contributed towards the emergence of object oriented paradigms. So, in that context, we start discussing about the three basic approaches that we need to do. One is the object oriented analysis. First thing you do is object oriented analysis. It is a method of analysis that examines requirements. So, please, this is a very simple statement, but please understand it very carefully. It examines requirements from the perspectives of the classes and objects found in the vocabulary of the problem domain. So, first you are doing a process of, you are doing an activity of engineering. So, what is the first question you need to ask? You certainly need to ask as to what is my input and what is my output. I am doing an activity. So, what I am given and what I have to deliver. So, if I look into object oriented analysis or the analysis phase, then what we are given is a requirement. That is, somebody, my customer, needs a system to be built, and the customer has expressed that need in terms of possibly natural language descriptions to me. Please consider, I am sure you have had an opportunity to take a look into the tutorial that we created for the first week, the tutorial on leave management system of an organization, where you saw two of our volunteers, Srijani and Tonni, behaving as customers and vendor to discuss about what leave management system is required. That requirement, so kind of you can say that the requirement is specified in terms of this video. So, this itself could be your input. Of course, we will not get you started with such a vague abstract place. We have also provided to you a 2-3 page kind of document, which gives you some more statements about what the requirement should be. And but that whole thing, whether the video or the diagrams or the text, are all kind of different, vaguely specified, incompletely specified, possibly inconsistent requirements that the customer has, and the customer herself may not be clear as to whether 100% of these requirements are really needed, whether they are really can be done, and so on and so forth. So, object oriented analysis is a process, is a practice that you will take up in view of this input to actually create a very basic level of identification for classes and objects. And while you do that, you will try to use the vocabulary of the domain. That is, the vocabulary of the problem domain is whatever is said in terms of the problem that you are given to solve, whatever is said in terms of the requirements document, the requirements video, diagrams, and so on. So, the typical stages could be this, that the first thing you would like to do is to identify objects. So, your system, leave management system, you have heard. So, what we were told? We were told that the organization has employees and they need a system to manage the leave of the employees. We were told that the organization, the employees in the organization are not of the same kind. There are 3 kinds of employees, executives, leads, and managers, and we were told the leave is also not of one kind. There are a variety of leaves, casual leave, earned leave, and so on. And if you go through the 2 pages of the document, you will find several different rules of how can you and one apply for a leave, how can a leave be granted, how much leave you are eligible for, what are the conditions of different leaves, and so on are documented. Now, the first task that we know that we are looking at a object oriented decomposition of this problem. So, the first thing we need to learn are what are the objects. So, some of the good guesses that we can make is certainly I can say that given this, employee is an object. given this, leave could be an object. Like these are good candidates. So, when you do identification, you say that employee is an object, you say leave is an object. But what about executive? What about lead? What about manager? These are all possible candidates for objects. Similarly, what about a casual leave? How about a earned leave, and so on. So, this identification process can lead you to identification of objects could lead you to several such different possible objects. There could be significantly different objects also. For example, if you read in the specification, you will learn that at some places it is saying that if a leave is approved, then an email is sent to whoever had applied. So, email also is a concept. So, you can say email is an object. So, there could be several objects identified, and as you identify different objects, you then try to see if you can have certain structure between them. That is, of all these different objects that you have here, are they really distinct objects or they are kind of interrelated, and we can say that okay, one commonality that we can see that these three objects are all of have something in common with the object employee. I can at least say an executive is an employee. So, anything that applies to an employee in general, employee has an employee code, gets a salary, has a designation, reports to someone, all of these will apply to executive, to lead, to manager, and so on. Similarly, leave, different kinds of leave, there could be several others, are leave anyway, that is when you get paid possibly, and but you do not come to office or you do not work. So, the next to identifying the objects is picking up a wrong color, is identifying structures. You try to see what structures these objects may have. Subsequent to that, certainly you will need to look at what are the how a concept like an employee or a concept like a leave, it is an abstract concept, it is an abstraction, right. It is just a notion, but finally the computing system, your final target is computing system. So, you will not be able to just keep a notion, you will have to get to that notion through a set of properties that the object can have, that concept can have, that abstraction can have. So, you will start saying that well, if it is an executive has a name, an executive has an ID, an executive has an address, same for the lead, maybe same for the employee, leave has a duration, leave has a start date, and so on and so forth. It must have an end date, etc. So, you start to really understand the objects, you start identifying attributes. So, these are the different attributes, these are the different attributes that you start identifying. Then you ask that well, I know now I know that there are different objects, I know that there is certain structure between them, I know that there are attributes for these objects, but for a system these objects must be interacting, the objects must be doing certain things together, certain things differently, must be sending messages between them and so on. So, you start working on the associations. So, you say that an executive can request, this is barely visible. So, I will use a different color again. So, an executive can request for a leave, I can say that a manager can approve some leave. So, there are these are different ways that the objects or structures that we have identified can be interrelated, can be associated. So, these will lead to different associations that we can have. And finally, to put all things together, you will now have to define what are the possible services that each and every object has to provide, what are the services that the system as a whole has to provide for making this useful, for making this conform to the requirement specification that you have been given with. And in this process, see, this is not a flat one way process, and while I just took the LMS example and quickly gave you some dirty, back of the envelope kind of reasoning, please do not get scared. We will take you through this in a very structured way over the next couple of modules. Idea here is just to illustrate that this is the process of analysis that you get started with, and as I mentioned that the whole thing is an evolutionary process. So, it is not that you will be able to immediately come to all the objects, get all the structures, identify all the attributes and have the associations correct, services correctly defined and have the whole design. You will do something scratch, then you will go forward and do certain steps of the object oriented design and find that, well, there are gaps in the design which you cannot fill up. So, it is kind of that is the evolutionary iterative process. So, you do object oriented analysis. So, this is where you got the requirement, you have done the analysis. So, you have objects, you have attributes, you have associations and so on, and then you do more of design. We will see what design will generate, and in the process we find that okay, things have not been completely done, there are contradictions, there are incompleteness. So, you come back and do the OOA again, you keep on doing this repeatedly, and that is the evolutionary iterative process through which you try to perfect your analysis. But whenever you are into analysis, what you are trying to do is you are every time you are into analysis, you either go back to the requirements document or to the requirements video of Tony and Srijani or to the diagrams, or even when things are not clear in those, you set up specific meetings with the clients, with the customers, with the interface with them and ask questions that, well, this is not specified, how do I design the system. This process is known as the object oriented analysis or the analysis process of our exercise. This is the first step. Next comes the object oriented design, which builds up on the analysis output that you are generating, and it specifically now talks of object oriented decomposition. So, you will find that it is though for the purpose of sake of presentation and understanding, I am presenting the analysis and design as if as completely separate phases. In practice, they will often be very closely related, that you do not just keep on identifying objects and identifying attributes or identifying structures and keep them on the side, and then you come and do object oriented decomposition. It is kind of you do them together. You identify objects, put them in the decomposition model, identify attributes, put them in the model, you identify services required, put them in the model, those are the messages. That is the whole process of regular process of decomposition that will happen. The second part of or the other characteristic activity of object oriented design is you start generating a whole lot of different models of the system. That is, you start looking at the system from multiple angles through multiple glasses, and there is no very specific exhaustive list of models that you will provide, that will specify. Some of the models are generic, will be done for all kinds of system, and some of the models are specific to certain types of systems. but it is typical that you will do logical models. Logical models are the basic fundamental object oriented models which identify, which represent the class and object structures. So, class structure you will recall the reference to the canonical form. The class structure is which gives us the commonality of behavior, the hierarchy of specializations, the hierarchy of abstraction, and the object structure is a compositional behavior that show that how objects are built up of smaller objects, how they in turn are built up of even smaller objects and so on. So, those are basically the logical models that exist in the problem domain. The reason they are called logical models is the fact that these models are completely or significantly dependent only on the problem domain and the requirements that you are given to solve, and not so much on the actual target system on which you implement or actual target system that you build, neither the computer or the architecture on which you are building your system, nor the actual system that you will build. So, the second set of models that you will typically build are called the physical models, because they are called physical because that is how your system that you have are constructing will manifest itself, that it will show that these are the modules. So, in terms of a typical software system that we are doing, these modules are certainly different collection of maybe source files, headers, libraries together, independent compilation units, maybe dynamic libraries and so on, which together does something meaningful as a subsystem. So, your in terms of the physical model, a module could be your email subsystem. In terms of a physical model, a module could be your employee management system for the leave part, and similarly the process architecture or the software architecture of the whole system, which could include the interconnect with the frameworks, which could include how your different modules interact between them, how really your messages are sent, how they are responded to, what happens if your situation gets into an exception condition and so on. So, these are the requirements of the physical model, and certainly we will talk about several behavioral models which are static and dynamic behaviors. That is, for example, if I talk about the LMS, a dynamic behavior that I need to know is when an employee applies for a leave, what happens in terms of the timeline, what happens, how will the manager of the employee who is supposed to look into the leave and approve or regret it, how will that manager get to know it, and when the manager gets to know it, what is the timeline through which within which the manager will respond, and once the manager has responded, how will the original employee who had requested for the leave will get to know. So, that is kind of the dynamics of the system, which says it is not only enough that you have leave as object or executive as object, or not enough to have messages to apply for leave or approve leave as services, but you also need to have a clear idea about the order in which these things will have to happen. Many of them have real time constraints. For example, I apply for a leave 3 days down the line, say today is a certain day X, and I apply for a leave, I am on Monday let us say, and I am applying for a leave on Thursday. Now, certainly whether I get to proceed on leave or it is regretted, I must get to know it before Thursday, otherwise I cannot take a decision. The system becomes inconsistent, and if you this is a quick example of, if you go back to the discussion we had between Tony and Srejani and the document that they subsequently produced, you will find that this question is not answered as to what is the timeline within which a leave must be reacted to. These are the part of the behavioral model that needs to be. So, in terms of the object oriented design, we basically refine on our findings from the object oriented analysis and try to start creating these models. The basic difference between these two being that the analysis is repeatedly looking into the requirements and bringing out stuff in terms of objects, classes, interactions, messages, and object oriented design is trying to put it in the terms of our actual paradigm. So, this is just for a recap. I will not go over this example once again. We had discussed it earlier as well. So, I am just making a reference to this, that we had talked about updating the contents of a master file, and this is what you will get to with algorithmic decomposition, and this is what you get to in terms of an object oriented decomposition. And you can see that naturally the process of analysis must have identified these objects, basic objects, and because it is somewhat vaguely specified in terms of the problem domain, but this comes from the vocabulary of the problem domain. The problem domain talks about a master file, talks about file of updates and so on, and based on that this kind of a diagram is getting created in terms of how the objects will interact between themselves, and that is the core of the object oriented design process. Naturally, all these different models that object oriented design needs to deal with have to be expressed in some concrete terms, and you will find that a significant part of our course is dedicated to learning how to express these models, which so far, even though we are saying that this is a concrete object, these are concrete attributes, these are messages, services, operations and so on, we need a mechanism to represent all these logical models, physical models, behavioral models and so on in some well defined, well structured language, and we will talk about that language, which is called the UML or the Unified Modeling Language. So, with this we have taken a look into the object oriented analysis approach and the basic object oriented design paradigm. We will now see how these two get stitched into the final system through the object oriented programming.